Hey guys, today we're talking about specific heat. So if you'll turn in your packets to page 17, specific heat, if we think about the word, specific means a certain, and heat is a type of energy that usually we can feel, okay? So some things heat up or cool down faster than others. Land heats up and cools down faster than water. So you know at the beach, your water takes longer in the summer months to heat up than the land does. So why is that? Well, like work, heat is going to be measured in joules. However, you'll still see it sometimes in calories as well. Because if you think about your body, when we talk about calories, it's how much energy is needed to burn however much you just ate, okay? So 1 calorie is 4.186 joules, and they are a transfer of energy. So let's talk about specific heat. The actual definition of specific heat is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree. So really, specific heat is how much energy do we need to heat this thing up. There is always, for each type of material, a specific temperature that is required to heat things up. So water, for example, has a certain specific heat. There is a certain amount of energy you have to add to water in the form of heat to increase that temperature. Okay, so why does water have such a high specific heat? Well, you'll notice that water and metal, like think about these two, have a lot different bonds. Water molecules form really strong bonds with each other, and it takes more heat energy to break those bonds and spread them apart. But metals have weak bonds, and it doesn't take a whole lot of energy to break them. So let's look at the specific heat of different objects. Okay, so it's the amount of energy required to raise the temperature of 1 kilogram of material by 1 degree Kelvin. Okay, so let's look at this. Water has the highest specific heat. It takes a lot of energy to heat up water. Alcohol is a little bit less, but aluminum, think about it. Aluminum is going to heat up a lot faster. It's a metal. It's a conductor. Its particles are closer together. It is a solid. Carbon is a solid metal. Sand, iron, a metal. Copper, silver. All of these metals are very easy to heat up compared to water. Okay, think about this. If we have aluminum and copper, which one will take longer to heat up? Well, aluminum has a higher specific heat than copper. So copper is going to heat up faster. So if we're looking at the math, we're going to have to calculate the specific heat. We have Q equals MC delta T. Delta means change in. Okay, so we know if there's a change in something, it has to be final minus initial. So we've got our Q stands for our heat energy, M stands for our mass, C is our specific heat, and delta T is change in temperature, final minus initial. Okay, so let's do an example here. A 32-gram silver spoon cools from 60 to 20. So we're given the mass, we're given the initial temperature, 60, the final temperature, 20, and we need specific heat. So remember, our formula is Q equals MC delta T. So we need the specific heat, and we're told that our specific heat is 235 of that silver. So if we work it out, Q equals MC delta T, let's multiply them all together. Mass is 32. We have to convert to kilograms. Delta T, final temperature minus initial, was negative 40. So we have 0.032 times negative 40 times 235. And our specific heat would be negative 301 joules. Okay? What about this? We have our mass. We have our initial and final temperature. So we would do mass is 230. Final minus initial. And we need our heat added, but we know our specific heat is going to be 4,184 because water always has the same specific heat. Every substance is going to have the same specific heat. So we have 230 is 0.23 kilograms. Final minus initial is 78. So we multiply all three of those together and we get our specific, not specific heat, our heat energy added is 75,061 joules. So the way they measure this is using a calorimeter. They have a stirrer, they have a conductor, these ignition wires going down into it. They have a thermometer, they have a piece of steel, and some sort of an insulator, sometimes it's plastic or styrofoam. And then they have reactants in here. A really cheap way of doing it is to have a styrofoam cup. And they can always measure heat and heat transfer using that. So that is all we're going to do as far as notes today. So what I want you to look at is your examples on page 19. We are going to do page 19 and 20. So be sure you look at these examples. We've got our triangle up here. I'm going to work some out on the board. Okay, I'm going to work these first 4 out. So if we look at this, we see that it says how many joules of heat are needed to raise the temperature of 10 grams, gives us our mass, from 22. Now what I'm not going to do here is I'm not going to change my mass into kilograms. You could, but for this case, I'm not going to require you to do that, just because it might add a little more of an issue. Okay, so we're just going to leave it in grams. All right, so I'm going to draw my triangle. And it needs to be a bigger triangle because you're going to have 3 things on the bottom. Q is heat added, mass is M, C is specific heat, and delta T is change in temperature. So how many joules of heat are needed? So we're going to be looking for Q, top. And it says the temperature of a 10 gram, our mass is 10 grams. Our delta T is final minus initial, so 55 minus 22 is going to equal 55 minus 22 is 33. So we're going to have 33 right here. And then our specific heat is 0.9. And you need to look at your triangle up at the top to make sure you know how to do this, okay? So let's look at it. If we take these 3 numbers and multiply them together, 10 times 0.9 times 33, you're going to get that your Q should be 297 joules. Okay, that is your answer. All right, calculate the specific heat. So remember, specific heat is C. So we're going to calculate C now. Remember what we do with our triangle. If something's on top and everything else is on bottom, we're going to divide. And now the biggest thing to remember is that you have more than one thing. If you've got something on top and something on bottom, you are going to divide and then divide again. Okay, so let's look at it. We need specific heat, so we're going to need C. It's a piece of wood that is 1,500 grams. So I'm going to write 1,500 right here. Okay? It says that my delta T, it changes from 32 to 57. I'm going to do final. 57 minus 32 equals 25. I'm going to put that right here. And then it says that we absorb 67,500 joules of heat. 67,500. And if you didn't know this, went here, look, it says joules. And if you look up at the top, your joules goes on top. Okay, so what we need to do now is we need to take this number right here, divide it by this, and divide again by this. So if you see a number on top, you divide. So 67,500 divided by 1,500 divided by 25 is going to give you 1.8, and that is your specific heat. We know specific heat is in these units right here, joules per kilogram degrees Celsius. And there's your answer. All right, now let's look at the bottom. At the bottom it says I have 100 grams of water at 4 degrees. It's heated until it's 37. So my delta T is going to be final 37 minus 4 equals 33 degrees Celsius. And I'm going to draw my triangle. I'm going to be kind of small down here because I don't want to move anything. But I know my delta T is 33. I know my specific heat is 4.18. 4.18. Be sure you're writing all this down in your paper. And my mass is 100 grams. 100 times 4.8 times 33 gives you 794 joules. Okay? And that would be what your answer would be for right here. So what I'm going to do now, I'm going to erase this, and I'm going to put my answers to the other side of this paper up here so that you can practice and pause this video and then make sure that you have the right answers on your paper. You can see how I work mine out. You have to use the triangle for this. It's going to be very difficult if you don't. So here are my answers for the other side. I'm going to zoom in on the first couple. You can pause this, okay? Now remember, go through and write your things in your triangle. Go ahead and pause this and make sure you've got the right answers, okay? And then I'm going to come down, and these are the last two answers. All right, and when you finish with that, I want you to flip over to page 20 and complete that as well. All right?